All right, so now enough of the talking. Let's get into the action. We'll get into RAM Modeler. And I like to say the first thing that you have to do within structural analysis and design is to model the structure, create the geometry. RAM is different than other softwares that in that it's specifically for building structures, these RAM structural systems. It's not generic that it could just analyze any type of shape. So the models, the structures that are typically modeled using RAM or only can be modeled using RAM is intended for building structures. So as such, it's not something where you could just input a nodal coordinate system directly. So instead of doing that, what RAM does is that it causes you, it requires you rather to input a grid. So all these other things right here, self-explanatory. I expect if you're using this program that you're gonna learn how to use it. You're gonna learn how to understand what's your interface here. Now, I'm not gonna go into the details of it because it just takes too long, right? So if I say layout, so typically we start on the layout. There's nothing else that needs to be set. Um, just, this the default stuff is which material we're in. This dialog box right here will tell you right here. This drop down box will tell you we're using steel. We could switch materials as applicable. We'll get into that later. Again, property tables, things that will be discussed as we go on. So here, the layout. First thing we want to do is we're going to create a grid. So it says here the grid system label. You can have different grid systems, quote unquote, that can be attached to different floor layouts. So we'll just design this for our main building, assuming that this is the grid. We would imagine that these are column grids that will continue throughout the complete height of the building. Um, that's why you can have different systems because sometimes the footprint changes as you go down or as you go up. Footprint changes, and you may want to modify the grid system in order so that you could just have a clearer picture of the content that you're modeling. All right, so main is what we'll call this grid system. This is our orthogonal system. The origins will be X, Y, and Z. There are no offsets to my location, X, Y, and Z. Obviously, I create radial system, but like I said, this is a simple structure, and we're going to use X, Y, and Z, or X and Y for plan locations. Z, so-called Z, will be our elevations. So we'll just add it. First thing you have to do is add it, and then you select it, and then click on Edit Grids in order to create a grid system. All right, so the X grid here, we're going to say that these are the grids that are transversing in the X directions. Okay, here I'm going to give it the labels of A. Sometimes this fools me, so we'll see how this goes. You would think that X grid would be, along the X axis, uh, and most likely it is. Sometimes some programs are a little bit, they have different directions from what we have learned in school about, X essentially being up and down. I'm sorry, left and right, and Y being what we consider to be up and down on our page. But anyway, um, the grid spacing here, as I said before, we're doing a three base structure. So our base spacing is going to be 30 feet. The number of grids that we need. Now, be careful here. It says number of additional grids. So we already are creating one, and what we'll need to do is create three more. as additional, not the total number. And I will have it to label the grids automatically as ascending. Other things like extend, limits to minimum y and limits to the maximum y. We could get into that later, but it's just a matter of how far is the grid extended left and right in this case. Um, Other things are really um, inconsequential towards the modeling's more graphical issues as whether or not the bubble is going to show up on the so-called I end of the grid, which is the left hand, or the J end of the grid, which is the right hand. Nothing needs to be changed. So here I have my settings and I say add, and it automatically created 4 grids for me with 30 feet increments between them. Let's do the same thing for Y. Here, my grid spacing will be different just because we're going to make this model different. My total number of grids is the same, so I have the numbers, total number of additional grids here, and all the other settings remain the same. But, obviously, the reason why I'm using 25 feet is just because I want to make sure that we could go back and back check the calculations um, in a rational manner that, I'm not having numbers that are same in the X and the Y totally in order to just add a little um, variation to the structure. All right, so we'll add this, and that's it. I usually tab out of these fields just to ensure that all the settings have taken place. And when you click OK, what you then have is nothing in your mind, right? You don't see anything happening. You created grids. You can go back and check it out, right? And you can say, edit grid. You'll see that you have these X and Y grids still there, but nothing has occurred on the screen graphically that makes you believe that you've actually successfully created these grids. So we don't see it. You need to see it. In order to see it, you need to create layouts. So RAM needs layouts so that it can essentially model floor plans. So you can think of a layout as a particular floor plan. All right. Uh, if you have the same floor plan, structural floor plan for the entire height of the building, you're only going to need one layout. If your footprint changes, you're going to need different layouts. All right. And you could create a layout for each floor, which is a good thing to do oftentimes in order to help keep track of things. But if the floor layout is the exact same thing on each floor, then you'll create something that's called a typical layout. And that's what I'm going to do here for anything that I model that are the same. Just call it typical floor. You have to add it, and then you select it. Now I am on the so-called typical floor. Again, the only thing that happened was this box was filled out, and you might have noticed some other settings have changed. Some icons became active. All right, so now I need to select a grid that applies to this layout. Here, I will select this grid main, and voila, we have our grid. All right, so the next step is to start modeling columns and beams. And I'll just keep it simple because that's the purpose of this particular layout is that things can be modeled really easy. So I'm going to I like to start with my columns just because I typically model things the way that they're going to be constructed if possible. So I start with vertical elements if possible, and then I go horizontal. I know foundations are actually installed first, But you typically want to model the columns, and then you'll put supports underneath them, and then you go horizontal. So modeling, just remember for the most part to be safe is to go vertical, horizontal, vertical, horizontal. You'll oftentimes be safe in terms of connectivities within the analysis programs. All right, so in order to lay out the columns, there are two ways to do it. You can select the icon, or you can go to the layout menu and select columns, and you go on grid, off grid. Okay. Once you click on this icon, you see that I get additional icons that pop up applicable to the selected icon. Here on grid, I'll just select on grid. This dialog box tells me that I'm going to have the ability to add columns to different orientations, so different properties, different sections, yield strength. All these settings are self-explanatory. So I'm going to model a standard column, not a hanging column or anything like that, just a standard column with supports at the bottom. I'm going to use gravity only properties right now. They're going to be W sections, so-called I sections, 50 KSI, and my orientation, as you see on the screen, that's the orientation you can use. You can also model columns at different angles if you desired, if there was a need. And oftentimes there is a need when we do real buildings to model these columns at different angles. But here, we'll just imagine we had the friendliest architect in the world and the friendliest client in the world, and nothing is at an angle. Everything is either well, at an angle to the x or the y. Everything is either parallel or perpendicular to x and y grids. Here, I would choose the vertical orientation. And then you can just model them all at once by fencing the area. On grid means that a column will be placed at each one of these intersections. Right? So that take care of the modeling of the columns. So cancel out of that, save my file. Every time you do something meaningful, you should probably save the file. You don't lose your work. Here we're going to lay out some gravity beams. Again, I'm going to lay them out on the grid. Once I select the icon, you see that the properties, the other additional properties change. I get some of the same stuff as I had before, like on grid, off grid. But these are just other commands that are germane to modeling steel beams. Again, the other way to do that is to grab it from the layout menu and start your command there more specifically. I like to use icons as much as possible, unless it gets confusing. All right, so on grid, take this thing, we'll model it. This dialog box comes up and it tells me, hey, what type of framing are you inserting here? Is it gravity or lateral? Are you going to use I section, so W sections? Uh, is it or something else? A rectangular channel here? All of them will be W sections or I sections. Is this beam going to be designed as a composite or non-composite? Here we're going to use non-composite because, again, keeping it simple. Um, these are other settings in terms of the graphics mode that are related to inserting beams graphically. We'll get into this. This doesn't have any bearing on what we're doing right now, as far as I'm concerned. So just don't change anything here. Leave the default as it is. 50 KSI units, again, just to remind you, it's in feet, but you can change it to inches. All right, so we'll add this beam. So no beam or wall has been selected. Okay, because I screwed up. I selected the wrong thing. I went off grid when I should have been on grid mode. So I knew that dialog box name a little complicated. All right, so this simplified version of the off-grid mode is actually a good thing that we went through the on-grid. I'm sorry, the off-grid mode. So this is a simplified version of the on-grid mode, and it's a good thing that we went through that off-grid mode because you can see that the dialog box with that is much more complicated in detail, which allows you more flexibility to do things that happen in real structures, real world. Here, this is simple. All right, so again, we've set the properties. It actually took the properties from my on-grid, I'm sorry, my off-grid mode, um, and applied it to the on-grid mode as defaults. And there I'll single out one thing and voila, create all these grids. Enough of the talking, right? So grids are created, beams are created at each one of these grid intersections. Now, just to be complete about this layout right here, as far as the floor, I will go ahead and infill some beams here. And RAM allows you to do that in an automated fashion versus having to create each one of these beams line by line, connecting dots to dots. You can just infill areas, you know, bay areas, if you will. So all of the settings as far as properties and the composite shape, composite flag or shape and steel, all that is taken from your previous dialog boxes. And here we set the number of equal spaces that we want per beam. So recall that between 1 and 2, our typical spacings in the y direction, 1, 2, 3, and 4 is 25 feet. So I'm going to use 5 feet spacing for this particular bay area because this particular model will just be a one-story building and the um, deck, roof metal deck will be used, and I typically space my roof metal decks at about 5 feet spacing maximum, just because that tends to work out pretty good for construction and design. Is a number that I have personally, nothing that you need to copy. You should figure out what works best for you, but 5 feet has been what I've seen over the past 20 years as a very good number. Also works pretty good with joists too. So 5 feet is a good number to use here. All right. The number of equal spaces per beam, I'm going to, since it's 5 feet spacing, I'm going to have 5 spaces between them, 25 feet. And sometimes this value right here tricks me, you know. Sometimes it ends up putting like 6 spaces or something like that. So it's either 5, 4, or 6. You know, you have to figure it out. But let's just say I remember how to do this, and it's 5. Uh, the angle from the beam line will be 90 degrees, and that's all that's needed here. So I will add it. You actually need to draw the line. You can't just click in the bay for this particular program, as far as I can recall. So we'll just add it, and so you draw it. You can just do it like this from point 1 to 2 on the A line. This little white line comes up with X and Y directions. It's asking you what side do the beams go on. Here's the interior side. That's where you click in the bay. So you do this, click in the bay, click in the bay, 5 feet spacing. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right. And you don't have to go in the order that I'm doing it. You could do it like that as well, just to show flexibility. Um, cancel out of that. Save your file. All right. So at this point, we've created a typical floor framing plan, columns and beams, nothing special, um, other than the things that hold up the floor and the beams, just for the gravity. And this analysis right here, this structure right here is currently modeled, will not be a stable structure because we don't have anything in the computer that lets it know that, hey, I need to take care of my horizontal loads as well as my vertical. So this is just gravity. It only considers vertical loading here. And if I want, I can do a data check here and see what types of um, concerns that RAM might bring up. I really don't know what's going to happen here. It might not even tell me I have a problem, or it might tell me something like, "Hey, I have beams but no decking," you know, and one or the other. So here's like, look, I can't even start this data checking unless I have the story data, right? So I need to know how tall is your building here, or what was going on with how many stories you had. So I must enter the story data for the model before running a data check. All right. So I basically only built the design in terms of the floor plan. Another way you know that is that these um, views, if you will, model views are inactive. I can't create a 3D view of this because it doesn't know what the structure looks like in 3D. No elevations can be created or no plans can be created. So I must include story data. This is also something I typically do from the beginning. So I say it's a one-story building, so I'll just say first story. Here, that will be my data information. If I wanted to, I could add various levels. That this is where you would include if you had a 20-story building. This would level number will increase. Here I'm on the first story. You see, I can't change this. This is inactive, so it's always going to default for the first story. It's keeping count. It's asking me, okay, well, your first story, which floor type are you going to use for it? I'm going to use the typical floor layout. Do you want to splice it at this story? We'll get into this later, but in general, splices just mean that I can actually get forces for the columns from this area, uh, from this level rather, if I splice it. If this was some type of intermediate level, we'll get into the splice later. Let Ram explain it, but as I understand it, it's really dealing with being able to extract lore, splice data, internal moments, internal forces rather, moments, shear, axial at various elevation. If I say yes, I can extract that information. Here's one story, so obviously that's the beginning and the end of the column. So how tall is it? I said earlier we're going to use 15 feet. Watch your units, floor to floor will be 15. Everything seems fine as far as the settings. We add it. Okay, and there you have it. Now I say OK, and it understands that I have a story that's one story. The name of the story is first story, typical floor, 15 feet in height, and it incidentally is spliced at this location. Doesn't really matter. Now, look at this. It's active. I could go into 3D. So let's see what this thing looks like in 3D. Okay, and I could roll it around by holding down the control key and my left mouse. Those are my settings, and that probably is yours as well. Um, to rotate the object auto access. I can get back into my plan view. It's going to ask me, hey, you want to go to the base? I didn't even know I created a base, or I did, but I didn't say anything about it. So that would be the bottom level. Or do you want to go to the first story? I'll cancel out of it because here you can either go to different levels or you can just click out of this. Make sure you click this bottom X on the tan box, the tan row, to close it, and it'll kick you back into modeler at that level. Save my file again. Now, again, purpose of this thing is to run a data check. We'll see what happens. I haven't defined a deck or anything like that. Here I'm going to run only gravity, but obviously you can check your data and have it run only for your lateral analysis. That's what it means by frame, or it could do both when you choose the integrated option. So I say, okay, see what happens. Everything appears to be fine as far as RAM is concerned. So far, so good. Whereas the elements that are modeled satisfy the data check status at this particular level for RAM. And I say that kind of in a legal way, if you will, to say that this satisfies RAM doesn't necessarily satisfy reality, or you can run this model. This just particularly satisfies this particular phase of what we've done. We don't have a diaphragm on this floor yet, but it doesn't mean that your model has an issue at this point. But for what we're modeling, we're going to need a diaphragm. Okay.